This 2024 November 27th, I will do a quick summary of linear algebra. I use book Linear Algebra and its application by David Lay. Today's topic is about vector and its length of vector and inner product. Inner product, we usually use this notation, and it is actually U transpose multiply V. If we represent it as vector multiplication, in this situation, you will be n by 1 vector and U transpose will be 1 by n vector matrix. There are some properties, which is U dot U will be bigger or same than 0, and U dot U will be 0 if and only if vector is 0 vector. And if we summarize the properties, then we can use this equality, which will be C1 U1 plus C to CP multiply UP will be same with C1 bracket U1 dot W, some of these things. And there's also another, I will explain the length. Length of vector is defined by dot product of itself as square root, which will be calculated by square sum of its element with square root, and C multiply U vector, C is scalar, can be written, we can write it as make scalar out and multiply the length of vector. And unit vector is, length of unit vector is same with multiply length of divide length of itself. So unit vector's length will be 1. If we make vector as unit vector, we say it is normalized. And distance of U, V is defined as U minus V, length of U minus V. And in this case, a very simple example will be U is U1, U2, and V is V1, V2 vector. In this case, U minus V's length will be U1 minus V1 square plus UN minus Vn square, which will be, we can also write it as U minus V dot U minus V square root will be same way. U minus V. And this seems suspicious, I think. It should be U minus V. If I something the length of U minus V, and if we visualize it, we can say there is U and there is V, then it will be length of U and it will be length of V, because this is 0.0, then this will be U minus vector U minus V, and this will be length of U minus V. And when we make this as this triangle, then in this case, U plus V, length of U plus V square is same with U square plus V square, if and only if the angle is perpendicular between the vectors. So we can also prove it by expression distance U minus U comma minus V, and distance between vector U and V will be expressed as u square, length of u square plus v square plus 2u dot v. And in this case, length of u square plus length of v square minus 2u dot v. If we want to make this same, only case is u dot v equals to 0. So when vectors a and v are identified in points, we can say the corresponding line to the points and origin are perpendicular if and only if u dot v equals to 0. And there's also another interesting proposition, which is 0 vector is always orthogonal to every vector of Rn, because if we dot product 0 vector, then it will be 0 for all vectors. And that product is same with 0 vectors transpose multiply vector multiplication v, it will be also 0. So that product is always perpendicular, orthogonal to every vector. Next time, I will come back with orthogonal complements and other concepts. Thank you so much.